Joe Celko. I'm probably best known for having put 10 years of my life into the ANSI Standards Committee and writing books about it. At some point, I was an honest Fortran programmer years ago. And the minute I started doing SQL, I was never allowed to do anything else. Oh, the pain, oh, the agony, but it's been a good living. However, I also, at one point in my life, was a statistician and actually worked with data. I think this is probably one of the things that us geeky programmer types forget about, where we become more interested in the hardware, the indexing, the mechanics of our trade, and don't go back to the fundamentals of what we're supposed to be doing, which is working with data. And we don't get a good theory or any kind of background on it, or any of the tools. You're just sort of left to figure it out on your own. So I have two manias. This is essentially two talks based on one of my books, which if you buy, I will be able to pay my mortgage. This is important. We're now getting the word data science, but frankly, data science, from what I've seen, looks an awful lot like statistics with a thyroid condition and a 6-digit paycheck. So maybe that's a good thing. But we really need to go back to the fundamentals of what data is, how we represent it, why there's different forms of it. In particular, anybody remember Donald Knuth? For the older people? Yeah. Teach the Knuth, the whole Knuth, and nothing but the Knuth. His Art of Programming is still one of the classics. What is it? They've got, I thought, all 8 volumes are out and a bunch of codicils. You know, it's about this much space on your shelf, and he's probably the greatest computer science guy we've ever had. He quotes everybody. Dijkstra quoted nobody. That's how you knew your indexing was good, because Knuth was encyclopedic. However, his first published work dealing with data was in Mad Magazine when he was in high school. Look it up, it's for real. The Potrzebie system of weights and measures. It's a parody of the metric system. The illustrations are by Wally Wood. If anybody else is a Mad Magazine or comic book fan, you'll know that name. And it's based on the thickness of Mad Magazine number 26. It's you have to be into particularly New York Jewish Yiddish humor, which was Kurtzman's thing, the editor of Mad Magazine, and the metric system to get it. The bad news about this, while it's good for a laugh in a humor magazine, you run into this kind of crap in the real world when people invent their own systems of measurement in data processing systems. Let's get a couple of, let's see, did I go too far? Yeah. Let's get a couple of terms for a measurement out of the way. The range of a measurement is how much area does it cover, essentially, in the space you're trying to measure. If I'm doing it with a gun and a bullseye that I'm trying to hit, the range would be how big the target is. Some things are appropriate for one size. Some things are appropriate for other sizes. What's the joke about close enough is very good for horseshoes and hand grenades, but not so good for surgery. Granularity is how many divisions do I have on my target? How many units of measure do I have? That one is one of my manias too. I used to work for a state highway department, and in the US we use feet. Yes, there are now only 2 non-metric countries left on Earth, and I live in one of them. Myanmar, or whoever in the heck it was, finally went metric, but it's still us in Liberia. But if you want to, you can carry out a calculation in decimal feet to several decimal places. But nobody has ever poured asphalt for a road or concrete for a bridge using a micrometer. But they will publish calculations that would be a 10,000th of a foot of asphalt. Ooh, can you say actually measuring that? No, it's ridiculous. Precision is how repeatable the measurement is. If I take it over and over, do I get I expect some errors to accumulate, but how close do I get? In the case of a gun shooting at a bullseye, how close is my shot group? That would be very precise. If it's sort of spread out all over the place, and it looks like I'm using a shotgun, it's not so precise. Accuracy has to do with how close it is to the truth. How close did I get to the bullseye? Notice that precision and accuracy are not the same thing. My target with rings, high granularity, maybe to the point that it's meaningless. Tight cluster of shots, accurate, but not necessarily precise. I've got a really good gun barrel, but my sight's a little bit off. So I'm always high into the left or something when I shoot. And the other way around, the scope is the scope's good, the barrel's loose, and I sort of, get in the general neighborhood. There's also the concept of a 0 point on a scale, on a measurement. It's where the scale starts. Where do I start measuring? Sometimes there isn't one, but it's a useful concept. This is not necessarily a numeric 0, but it's where your scale starts. There's also a metric function, which is basically triangular inequality, if anyone remembers that one from high school algebra, as a property. So that if I've got a metric property, a function and metric properties in my scale, I can do calculations with them. And they can be meaningful. Now, what's sort of funny is scales and measurements actually didn't come in until the 1940s as a science. You would think that somebody before that in statistics or something would have come up with it, but no, it was a little late in coming. So what's the simplest scale I can use to measure something? The nominal scale. Take your values, assign a name to them. In fact, a lot of people don't even like to count this as a kind of scale. That name, by the way, can be a tag number, a character string, or technically can be a symbol. We don't like to use symbols very much. They're a bitch to put into a computer, they don't transport very well, and they're not always obvious. The advantage of using a symbol to measure something, to name something, is that it's language independent, completely language independent. If you want to look at some really beautiful examples of that with a really elaborate system, get a book on Renaissance artwork. The stone cutters in Italy, who were working for Michelangelo and all those guys, were pretty much illiterate. And they all had individual marks they put on each of the sculptors had an individual mark that he put on the pieces of marble he was getting. And then little tags and other systems off of those marks showed the father, the son, the grandson in given families. They look like alchemist symbols. Be grateful that you do not have to put those in any database you're ever going to work with. They're just a nice little piece of artwork, and that's it. I can't do any calculations on a nominal scale. About all I can do with a nominal scale is ask, are you Fred Jones? Is this your name? The crudest form of a scale. Also one we use an awful lot. And we do a bad job of it, by the way. Naming things inside databases is could be better. Let's be kind about it. If I represent it as character strings or numbers, I can order them. But I'll be doing an ordering on the symbols, on the representation, rather than on the meaning. These are individuals. There's no grouping or category yet. I told you this was the simplest way to do it. The next level up is a categorical scale, where I've got a group, a property, a category with a name. Sets. I'm back to just a simple bunch of sets. Fido is my dog. Dogs are mammals. I can do set operations. That's it. Union, intersection, all that good stuff. Categories are important, and how you, when we get to the encodings, how you work the categorical scale is, It's a little trickier than most people think. Problem is with these categories, can I have them overlap or not? What happens when I get something that's weird? Any Robin Williams fans? Or is he pretty much an American thing? Okay, I thought he would be more international. But one of his routines when he was doing nightclub stand-up consisted of God smoking a joint and deciding, I'm going to make a platypus. That'll fuck up Darwin. So how do you classify a platypus? Is he the only guy in his category? No, it turns out there's actually about 4 other egg-laying mammals. The others are echidnas. Of course, they're in Australia. All the weird stuff goes to Australia. What do I do when I've got something that just doesn't fit? Say a Martian. I can make a new category. Okay, I have to have allowed for new categories in my codes. I can make a miscellaneous category. That's a good way to screw up things, because miscellaneous winds up being so mixed that you can't do any meaningful work with it. Everything you forgot about, it's like your garage. It gets put in the category and piles up until somebody comes and cleans it out. Or you can just pretend it doesn't exist and exclude it. Now, the other question with a categorical scale is, can I actually see individual members, or are they simply members of a group? It's worth telling people apart. It is not worth numbering grains of sand. The idea of a commodity in a categorical scale is a little hard for people to get their heads around. Absolute scale is just a count on the set. I can add, finally I can do some math. I can add and subtract numbers. The gimmick is, for an absolute scale to work, all of the elements in my groups have to be interchangeable. It's a dozen eggs. It's not egg 1, egg 2, egg 3. It's a dozen eggs. And we tend to give names to these units. The dozen, the gross, quire, ream. Oh, I'm sorry, which ream in the paper industry? There's about 3 of them. 500 versus 450 sheets of paper of certain sizes. My favorite, of course, the 6-pack. It's not a drinking problem, it's a solution. What was funny was in England, when they went over to their decimalization, way back when, one of the dairies there put out a 10-pack of eggs. I'm sorry, English-speaking countries traditionally, metric eggs. Ooh, big promotion. English-speaking countries have a love of dozens for eggs. It didn't sell. Never mind the cost of the eggs. And those 10 packs was actually cheaper than they had been in the original dozen packs. People, it was just too strange. All right, if you went to a beer store, would you like to buy a 6-pack or a 5-pack? Even if the cost per beer was cheaper. Wouldn't it just seem somehow wrong to bring home a 5-pack for the kids? Those traditional units really get locked in. Okay, obviously I've got a 0 point on this scale, the empty set. An empty egg carton is where things start counting. Ordinal scale. I'm going to put an order on something. No operations, just comparisons, just a sequence. No origin, no 0 point. Anybody else have to take a geology class in college? Yeah, so we've got at least one geology victim. The only nice thing about geology, as far as I was concerned, was they gave you an axe. And you go out and hit rocks with it. The rest of it, I have never had to use anything I learned in my freshman geology class at any time. It did not help me pour concrete for a driveway, or absolutely useless. But when we went out to the field to whack at rocks with our geologist pick, we got a box of samples called a Mohs scale. And it was mineral samples in a tin compartment box. And what you would do is you would take your sample and scratch it on the various elements in the Mohs scale. And you could say, well, this is harder than talc, but softer than gypsum. By what could scratch what? Strictly a comparison. It is a quick, easy way for someone running around in a pair of shorts with a pickaxe and this box of rocks in a field getting poison ivy, because he has to do this for his freshman science credits, to carry things. The real way to do hardness would have been the Rockwell scale that's used in manufacturing for steel and other metals, but we didn't have that. Oh, by the way, they never gave you a diamond in your Mohs scale. Usually there was a piece of really hard steel in there. So technically it wasn't, but what did you expect when you went to the school bookstore to get it? But just a comparison, just a linear ordering. Oh yeah, a little thing about ordinal scales. They're not required to be transitive. Ever play scissor, paper, rock, or some of the other games? What's the one on Big Bang Theory? Spock, yeah. Yeah, have you seen the T-shirt with the non-transitive ordering of those things? Okay, we really hate non-transitive relationships. We want a transitive relationship. We want it properly, tightly, well ordered. You can't make calculations or anything much off of a non-transitive scale. It's also, non-transitive scales are also the tool for fixing elections when you have more than two candidates. Look up Arrow's paradox, and that it's impossible to get a fair voting system if you don't have two people in a tight ordering. Rank scales are sort of a tightening on ordinal scales. There's an origin point, they're well ordered. They're guaranteed to be well ordered. Military ranks are, of course, the obvious one for that. Can't do any operations on them. I cannot take three privates, put them together, and make a sergeant. The ordering still stands. If you shoot your sergeant, you still have to take orders from your captain. The transitive ordering is tight. We like those. I might not be able to do much math on them, but I can sort them. Sorting is good. Interval scales are really when you say scale and measurement to people, this is what they think of. There's a natural ordering to the unit. I don't have any origin point, but arithmetic makes sense because of my units. It's uniform in its dimension. Most common interval scale you use, calendar. Your common unit is a day. Regardless of how you cut up your year or group your days together, you've got a common unit, the day. I guess you guys might not get much of this, but for some reason among Christian fundamentalists in the United States, there is a belief that God made the 7-day week. No, actually the Hebrews did. The Romans had a 10-day week. Parts of Africa had 10-day weeks. How do you want to cut up your units? Completely arbitrary, but I've got a metric function. I can add and subtract, and I've got a linear ordering. I can't divide 2 days by each other. Christmas divided by Thanksgiving doesn't mean anything. One of my favorite t-shirts right now is, on a scale from 1 to 10, what color is your favorite letter of the alphabet? No, I show that to people when they're starting to do stupid stuff with their data. And what's funny, when you ask somebody that, they'll stop and think about it. They will try to answer you. It sounds like it ought to be a real question. And if you've seen what they've been doing, you understand why they think it's a real question. Now, the intervals on these scales do not have to be the same size. In fact, log and exponential scales are a lot more common than you think because you're a human being. Your sensory input and a lot of things you do for judgment off of sensory input go on an exponential scale. My favorite is the Richter scale for earthquakes. Each time a Richter number goes up one, it's 10 times the magnitude of the previous unit. When you adjust volume on a stereo, it doesn't go up linearly in the amplifier. It goes up, I believe it's something to the 0.3 power, 1.3 power. It's, at any rate, it's not linear. It amps up. And a lot of stuff is exponential. Decibels are another, go up by powers of 10. Now, having lived through a 7.8 earthquake years ago in Los Angeles, I appreciate the Richter scale more than I did before. When you look out your window and you see a bridge collapse, you know, Now, ratio scales are sort of the ultimate. And that's what, when you say scale or measurement to someone, this is what they think of. I've got a natural origin of some kind, 0 point. The scale's got strong ordering, and the unit is uniform in its dimension. Length, width, height, all the things that you would use commercially are ratios. It's called a ratio scale because everything is expressed off of a single unit as either a fraction or a multiple. Remember the Potrzebie system of weights and measures? Or the metric system, if you want to use a little better example. Multiples of 10 or fractions of tenths. Nice, handy, easy to work with. Oh yeah, and we've got this number system that the Hindu Arabs invented for us. I often wondered about the Hindu Arabs, but when I was a kid, and we use Hindu Arabic numerals, and I had never met a Hindu Arab. Now, why are the classifications of scales important? Because if I'm going to convert between scales, they have to be of the same type for the conversions to make sense. If I do a nominal to a nominal scale, it's a mapping. One-to-one mapping, preferably. Oops. Okay, we've lost picture. Is it falling asleep? Yeah. And it's back. And it's a little bit ahead. Okay. So nominal scales, one-to-one mapping. Gee, since we're in Canada, French-English dictionaries. So you can get to a one-to-one for at least some of the terms. Ordinal, monotonic function that preserves the ordering. Not necessarily the same values on each scale, but I want to preserve that ordering. And well, that's why we call it an ordinal scale. I say value of Western and Chinese chess pieces. That's not a particularly good one. Maybe the dates on calendars. Rank-to-rank scales, monotonic function, preserves the ordering. Might not always be a good match. Army to Navy ranks, the equivalence there. In particular, I don't know if this is still true, the U.S. Army used to consider warrant officers to be officers and gave them officers' privileges. The British Army considered them to be enlisted, and they didn't get officers' privileges. There would be various cut points, but a mapping. Interval scales, linear function, and shifts the origin point. We're getting back into simple conversions. Celsius to Fahrenheit. 9/5 plus 32. Did I get that right? I just remembered zeros freezing, hundreds boiling. 25 is a little colder than I'd like it, and that 30 to 35 is comfortable. I live in Texas, and I keep my house set at 80 Fahrenheit. Yes, it's a little unusual, but you lose a lot of heat through your scalp. Now, ratio scales, constant multiplier. Liters to quarts, 2.2. Exact conversion. That's why we like ratio scales. They're easy to work with. Interval scales, okay, I got to do a little math, but ratio scales. simple multiplication. Now, derived units. We have the concept of a primary unit. This goes over to the metric system, actually System International. And the ISO standard 2955 is where they've got all of the official definitions for the derived metric units. Kilometers per hour, square meters. Can be all kinds of combinations on different scales. Some of them will not make sense, but pretty much you can put any two primary units together, multiply them, and get something that's meaningful. If you ever look at the definition of a Pascal as a unit of pressure, there's a little more multiplying and dividing in there than you might like. But, okay, gross general statement. In a database, if I'm going to derive something, have a derived unit, I had really rather do the calculation in the database from the simplest, most primary units I can store. This is a generalization. That way, if I need to do something else with them, I don't have to try and pull out the primary units to get them again. And multiplication's cheap. And computers are real good at this computing thing. So in the old days, yes, when people had to do it, it was a little more work than we'd like, but it was worth storing the computation rather than the basic units. As a generalization, let the machine do the computing. It's actually faster. Your processor is working in nanoseconds. Your disk drive is still a lot slower than nanoseconds, even if you're doing solid-state drives. So it's actually faster. Okay, quick summary on scales. From weakest to strongest: nominal, categorical, absolute, ordinal, rank, interval in its various forms, either linear or log, and finally ratio scales. Okay, now that's usually one lecture sort of stretched out when I'm doing this for a class. And at this point, you would all be drawing a 3x5 card. Oh, that's inches. An A5 sheet of paper with something written on it, like ring size, shoe size. And you would have to go to Google or the library and look up exactly what kind of scale you're using. This is going to be bad. Code it. Make it easier to work with. Now, we're getting into a database of symbols, and frankly, thanks to a wonderful thing called Unicode, the representations are going to be alphabets, actually a subset of the Latin alphabet, the bottom of the ASCII characters, numbers 0 to 9, and some symbols. And I've got rules for manipulating the codes. I got math for numbers, I got string operations, and technically these days I can put data directly into the databases, but we really don't like to do that so much, or at least us old SQL guys that never really got over the idea of having graphics and that sort of stuff in our computers. Don't like it. They're hard to search. One of my favorites was a couple of decades back. IBM was pushing picture recognition. It will probably be face recognition now. And they had examples of their wonderful product where you could sit down with some colored pencils, draw a quick picture of something, and then search photographs with your drawing. They were trying to do a general, face recognition is a whole science in itself, but they were trying to do it very generally. Their example was finding a banana in all these pictures of fruit. It found the bananas. It was actually quite good about that. It also found a toucan. He showed up as a banana. So we're still working on it. In particular, we got Unicode. Let's put all the alphabets and symbol systems known to man in 16 bits. It's a nice ISO. It's a nice ISO basis for encodings. The ISO people specifically wanted to get this minimal subset in all the languages on Earth. This is why you can write a VIN number in Chinese. It's part of the Unicode set, or any of the other languages. Latin alphabet, no accents, no case sensitivity. Some of the positions can be numeric. There might be rules for disallowing them, so that we don't get confused, or where the digits and the numbers can appear. And a minimal set of punctuation marks, pretty much commas, dashes, period, or dot, I guess if it's in an encoding, slash and underscore about it. Things like, and I actually know the names for these, octothorpe. It is not a hashtag. Typesetters call it an octothorpe. And that little thing that you think is an and, it's an ampersand. All of them have rather fancy names, but the @ sign is technically the little snail. It sounds much better in French, but that was the official name. The trouble with the special symbols is that they have meanings in other languages and systems. Remember when Microsoft was talking about how they were going to really get on this internet thingy-bob and do their part and blah, blah, blah? Well, they named something C# without any knowledge that the octothorpe had meaning on the internet. Gee, that's careful research, guys. You're really into this. But when I'm doing an encoding, the display is important. Encodings should be convenient for people. You know, those damn users. We'd have such wonderful systems if it wasn't for the users always screwing up something. In particular, when I've got an encoding, I can either do fixed or varying length. I would prefer fixed length. The length of a code is part of its validation. If I see 5 digits, I know it could be a US zip code. If I see a mixture of digits and letters, I know it could be a Canadian postal code if it follows the right pattern. Was it letter, digit, letter for the first part? No Canadians here?
It alternates all the way through.
Yeah, but the other one, if you want to really go nuts, get a copy of the British system. It's between 4 and 12 letters and numbers that are actually the abbreviations, or attempts at abbreviations, of old post offices that existed in the late or middle 1800s in England. It's completely unusable and unparsable. It's so bad they're introducing a 5-digit commercial code based off of the US zip code for bulk mailers, because their own system has proven to be so unusable. Oh, also the Royal Post Office, the Royal Mails, have a monopoly on their guidebooks for doing the addresses. It's illegal to set up your own postal code service in the UK. You're a government at work. Now, fixed length also has another advantage. Everybody remember printers and paper when we used to get our data on that stuff? Well, that goes back to the old punch card days when we had fixed length fields, fixed length columns, fixed length displays, 80 columns across on a 3270 video screen. But more than that, it's something a person can see and can line up. Varying length gets confusing. That's being nice about it. Okay, the worst standard we'll probably run into is not the British postal codes. It is a thing called the IBAN, the International Standard Book Number, bank account number. It is 50-something characters long. It includes the account numbers, the country codes, a whole bunch of stuff crammed into this one unreadable string that only a machine on a Swift system can figure out. People that work with it can't read them. Now, people who work in the automobile trade can read a VIN number, which is only 19 characters long, but nobody can read an IBAN. The thing is, with human processing, you don't read letter by letter. You read in chunks or bomas. You cluster things. 3 is the best. People will get 3 digits or 3 letters correct almost all the time. You can go up to 5 very safely, but beyond 5, you start getting errors. In fact, there are 4 common errors: missing character, extra character, 1 bad character, and then pairwise transposes. That's probably from typing, but pairwise transposes are the 4th most common. For example, phone numbers are grouped into an exchange, a dialing area, and then the actual phone within it. And it's very convenient to read it that way. And I'm doing okay on time, I think. Okay. Now, what about bad encoding schemes? Well, one of the characteristics is there's no room for growth. In the 1970s, when we're still on punch cards, in the state of Georgia, down in the States, we had autotype codes. It was 1 punch and a punch card. And it was originally taxis, private vehicles, farm vehicles, just 7 or 8 of them for the type of license tag you got. That was very nice and it worked fine. Then along came a thing called commemorative tags, which state governments loved because with a commemorative tag you could charge extra. Great revenue source. California makes a few $100 million off of their commemorative tags. So every group that had a cause, every college, veterans group, whatever, wanted a commemorative tag. Would you like to be kind to animals? Fine, that'll cost you $35. And you can display it on your license tag and look better than your neighbors. The problem is we wound up having to put all kinds of different codes. I mean, when I left, it was about 35 of them, because every college had to have its own commemorative tag. So how do you get 35 different punches in a... Okay, how many people have ever worked with a punch card? Maybe I ought to ask this.
5.
Thank you. Yeah, thank you. Now, usually when I do that, I get what I call my fish market. All the kids, that's people under 40, sit there and go like dead fish, mouth open, eyes glazed, looking at you. So we found that you could multi-punch. You'd hold a key down, and then you'd punch several combinations. And it's 12 columns, 12 rows to a column. So you had 2 to the 12 possible combinations. And you had a little translation thing to the side. Oh, wait a minute. We had 029, 027, and 028 IBM key punch machines, which are all a little different, and UNIVAC key punch machines. So you not only had to know what the multi-punch was, you had to know what machine you were punching it on. Otherwise, the tags would get all messed up. No room for growth. If they had allowed 2 digits for the license tag type, it would have been no problems, and it would have saved us quite a lot of work. The other one, how many people have ever worked with COBOL? Yeah, I mean, don't tell Mother, she'd be so ashamed. She thinks I was playing piano in a whorehouse. But American Honda, for their dealerships, figured we would never have more than 10,000 dealerships in the United States. This is when they were bringing over the Honda scooters. Do you remember the Beach Boys song, My Little Honda? Google it. I'll tell you about hip hugger bell bottoms and mini skirts next. But they didn't allow room for that, and they had to redo all of their COBOL files. You don't think about this with SQL. If we want to make something, we've got an abstract view of data. If we want to make something bigger, we just change a check clause to give us a different range, or we alter a table. You don't do that in COBOL. What you see is what is processed. Everything is character strings, exactly the way it appears on the physical media. It was really a major leap, but no more than 10,000 dealerships. Remember, was it Bill Gates? Why the hell would anybody need more than 64K on a home computer?
40.
Was it 40? Did you say 40?
640.
640, yeah. And now you've got a watch with more than that. Now, another bad encoding scheme that it happens more than you think is ambiguous codes. My favorite example was the old International Standard Book Number, the ISBN. This is because I used to own bookstores. It was 10 digits made up of 4 parts. The first 1 or 2 digits, variable length pieces, was the language. 0 and 1 were English. 93 is Esperanto. That was sort of the end of the list. I don't know where Klingon and Dalrathi figure on the scale, if they're in there or not. They might be. The publisher's code, the bigger the publisher, the shorter the code. 3 digits or up to 7 if it was a small one-time thing. The book number within publisher, and then a Mod 11 check digit. The catch is, without any punctuation in the 10-digit ISBN, you can cut it up various ways. And in the early days, they had ISBNs that could be parsed 2 ways. There were about 15 or 16 of them, and it was enough to mess up libraries for a while. That has since been fixed, and the ISBN is good and usable now, and it's part of the EAN codes. Okay. Miscellaneous code, if it gets used a lot, something's wrong. You skip too much. Now, the other thing with a bad code, there's no support for exceptions. Everything just gets into that miscellaneous category. But I can have unknown values, missing values. Oh, wait a minute. For us, that's a null. When you have a nullable column, how many of you bother to actually document what the null means in context? Does it mean that something's missing? If I have a null phone number, does that mean I don't have a phone? Or does it mean we don't know his phone yet? Non-applicable, something just came in crazy. The non-applicable you probably laugh at, but I just got through working for a company called MIB. No, they're in the insurance industry. They've been in business for well over 100 years. They did not get their name when the movie came out. But they get kidded about it when they go to insurance conferences and occasionally wear sunglasses. Their thing is they get dirty data coming in from the insurance companies, so they need a rather elaborate set of non-applicable values. I've already mentioned miscellaneous and unclassified. It's bad design, you've missed something. Overflows, underflows, bad divisions, computations that are garbage. Now I can have an error in one field, that's, take care of that. But how about where 2 fields are related? A medical record that shows a pregnant man. Bruce Jenner is going to be so disappointed. Have to get that in. How about it's computable, we could find it, but we don't know. There was a Sparks committee back in 1975 that issued a list of 14 different kinds of missing data. Later on, a follow-up to the Sparks committee report gave us 22 different kinds of missing data. And statisticians have all kinds of ways of trying to correct for the missing data. If you're dealing...
They had 8 missing.
Yeah, they missed the missing data. Now, if you think that designing encoding schemes is not important, try doing math with Roman numerals for a week. In fact, Roman numerals were such a bad encoding system that even the Romans didn't do math with them. No, they looked it up, and they had lookup tables for division and multiplication. Try living without alphabetical ordering for a week. In Hong Kong, I don't know if they still do, but in Hong Kong, the telephone operators used to have a contest every year where you would call, where they would identify somebody's phone number from their name. And the winners of these contests would have memorized 10,000, 15,000, 20,000 different names and phone numbers and be able to spit them back. I had a friend who taught English in China before Tiananmen Square, and she would get her class roster of 150 students, translated into Roman letter, but it was never sorted. No alphabetical order. And it was never the same order from week to week. Well, everybody can memorize 150 names, can't they? If you're used to working with Chinese. Not so good for an English speaker. Go to a library and try and find something without the Dewey Decimal Classification. Dewey Decimal has some problems. I'll get to that in a little bit. But I mentioned this thing about organizing a library by color. Actually, before the Dewey Decimal classification system came along, every college library or public library had its own individual classification system invented by the head librarian at that particular school. My wife volunteered for a feminist bookstore in the 70s in Atlanta, and one of their people was definitely not a book person. She did sort the books in the store by color because she thought they would look pretty. Do not work with hippies if you can help it. It will not end well. The drugs will be good, but it's not worth the work you have to do afterwards. If I've got a good encoding scheme, my aggregations and queries and so on are easy, much easier. Again, going back to Dewey Decimal, if I want to look up science books, I know they're in the 500 series. If I want to look up math books, I know it's in the 510s. I can immediately zoom in on a small subset. I can use between predicates in my SQL. You'll also find your calculations get to be a lot more accurate. You don't have to worry about things on borders and fuzziness. Okay, kinds of encoding. Enumeration. Make a list of values, assign a name or a number, tag number to them. It's really a nominal scale with a name attached to it. If you can get some kind of ordering on the symbols, that's nice. Chronological, procedural, some sort of physical thing. The bad news about sorting codes by alphabetical or numeric order is what languages were you using for the alphabet? Canadians are probably a little more aware of that. But how many times, okay, I have to hit on SQL Server people because they are the worst SQL programmers on earth. They're all VB programmers whose boss wouldn't pay to send them to a course. And they learned it at home in a weekend. They will use their auto increment, their identity column, just make a list of things, and whatever physical order the values happen to be in the table, in the physical storage, that becomes the encoding for it. No logic, no thought, no nothing. Measurement codes. Okay, I've got a unit of measure. I put the units in. I know it's for that column, and I express it. And yeah, I may have to tell what unit I'm using, but essentially it's just a recording of measurements. Worst design is to put the unit of measure in the same column as the value of the measurement. $sign with the dollar amount, that's COBOL. Why? Because COBOL was concerned with physical display. There was no difference between storage and physical display. You'll still see people do it. You need, if you have mixed units, you need to have a column that tells us what our unit of measure is somewhere. Okay. Abbreviation encodings. Take a shortened version of the value, the name of the value, and come up with a, usually if you can, fixed length abbreviation. The goal of an abbreviation code is to be people readable. I'm going to assume everybody, for the most part, flew here. Did you notice your 3-letter airport codes?
Yeah.
It doesn't take too much to figure out that BOS is Boston, or ATL is Atlanta. YOW? Not so much. Yow. I'm going to wow Canada.
Y is for Canada. Yeah. Y is
Yeah.
the letter for
Yeah.
Canada.
And the same thing with some of the smaller, really small airports in the Great North and in Alaska. You can't Z's and W's on them, but You get some pretty weird ones that just are not intuitively obvious to the casual observer. The nice part with abbreviation codes is that business about a human being figuring it out. Don't fight your user. Algorithmic codes, I've got a procedure, I encode the value, it might not be immediately human readable. In fact, in the case of encryption, it better not be immediately human readable, or I've got some real problems. You don't think about it, but rounding a number is technically an encryption, is technically an algorithm. Hashing functions, where there's no way to look at them and immediately tell what the originals were. Hierarchical codes, I really like hierarchical codes. I fell in love with Dewey Decimal. But they're usually numerics, but they can be mixed alphanumerics. The Library of Congress system for libraries is actually more accurate than the Dewey Decimal, and it's mixed alphabetic. Zip codes in the United States are based on geographic partition. If it begins with 3, it's in the southeastern United States, multiple states. And then bit by bit, as you go from left to right, it gets more and more accurate. So 300 would be the southeast, 303 would be parts of Georgia, 30310 would be a subset of Atlanta, Georgia. And it's nice and easy to look at, and you've got an idea when you see the code what you're zooming in on. Now, bad news with it. You can put stuff in the wrong part of the hierarchy. Dewey Decimal put logic under philosophy. Why? Because when Melville Dewey was inventing this system, George Boole had not written the laws of thought, and there was no mathematical logic. When's the last time you saw a philosophical logic book? There may have been one written, but for the most part, nobody's written philosophical logic for the past 150 years or longer. It became a branch of mathematics. So it's a little messy, and we've gradually moved logic more toward math in the Dewey Decimal System. What if I don't have enough space in my hierarchy for some things? In particular, one of Melville Dewey's other prejudices was that there were Catholics, Protestants, Jews, Muslims, and miscellaneous. The Library of Congress has more books on Buddhism than it does on Christianity. They've been writing longer. There's more breakdown of subsets and whatnot in the Eastern religions, but they all got put in one miscellaneous religion. It's an old British cartoon of a sergeant major standing in front of his Indian troops. Church of England to the right, Prots in the middle, Papes to the left, and your fancy religions to the back. And that was pretty much how Melville Dewey saw it. What happens if I've got an item that could reasonably fall under multiple codes? Church architecture and the worship service could be under religion and architecture. You don't think about it, but Christian churches are laid out as a cross. That affects how we do our ceremonies. Did you know the aisle is the short arm of the cross? So when the bride walks down the aisle, traditionally it wasn't down the long length of the church. It was originally from the sides. The Muslims have a square for a mosque. And there's other things where the architecture affects how the service is held. It's really kind of an interesting topic. Where do you put it? Architecture or religion, or both? Well, the solution for the librarians is whatever the Library of Congress says is the code is where you put it. Okay, we're now running out of time. Vector codes are made up of parts, but the whole has to be there. The components can be independent or dependent on each other, but the whole code is a unit. My favorite is ISO tire sizes. A 155 SR15 is metric width. The SR stands for steel radial, and then the diameter is still in inches, but that's going to change soon. And obviously, I cannot have a wheel without a width, a diameter, and it's got to be made out of something. I cannot take any of those components out. They're pretty much independent. The Social Security numbers are a US thing. That needs to be removed. We've now done away with meaningful Social Security numbers because we have so many illegals. They're now being assigned randomly. Yeah, it's that bad. Concatenation codes, variable number of parts, I just keep adding on to the end of it. They can be ordered or unordered. You don't think about it, but a keyword list at the front of an article from a limited vocabulary is a concatenation code. Checklist, yeah. They were called facet codes in Europe. They're not in favor so much anymore for designers. It used to be when they were physically written down and they were literally concatenated, and you'd initial each step in a process. They were popular in the aircraft industry, but not so much anymore. Okay, guidelines. Do not reinvent the wheel. Okay. Oh, good, my pacemaker was working. But you can research encoding schemes. Do it. It's quick and easy. Can you say Google? Google is our friend. Google's better than anything we ever had when we had to go to paper copies. Now, here's the bad news on Google. It's too good at times. So you really need to know your industry. In my book, I have a whole chapter on sex codes. The standard one that we'll probably use is ISO 3166, 0 for unknown, 1 for male, 2 for female, 9 for lawful person, like corporation, organization. Then there's a whole bunch of other codes used by biologists. People are very dull. Other than Bruce Jenner, we don't change around a lot. We just generally come into flavors. But when you get to the different biological codes for all the medical stuff, woo! Which one do you want to use? Probably for commercial stuff, male, female, unknown. Oh, by the way, the reason for 0s and 9s for the unknown in the miscellaneous code in the ISO sex codes is punch cards. In the old days, a blank column, an unpunched column, would be read as a 0 by Fortran, and you could also make COBOL read it as a 0. So that way you could take the card, the unit record as it was called, and repunch it when you found out what the code should be. 9s were easy to do on a key punch machine. You just hold the key down, fill it with all 9s, and that way it would always sort to the bottom of the report. Yes, the encoding schemes were designed for the physical use of a key punch machine. A lot of things are like that. Why are railroads a certain width? Because, I don't know if you've heard this one, why are the U.S. railroads a certain width gauge on the tracks? Because we followed the British pattern. What did the British pattern follow? The Roman chariots, the width of a Roman war chariot. So we've been following horses' asses on our railroads for years. It's, the exceptional value should be explicit, allow for expansion. Also, this is going to sound really dumb, but you'd be surprised. Actually put a translation of the codes in a database somewhere where somebody can get a machine version of it. I wish I was making that up. But when I had my first set of eye surgery done in Los Angeles at Cedars-Sinai, a major hospital with a good reputation, blah, 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 I went down to fill out the forms. The clerk had a loose leaf notebook with all the codes so we could punch the medical codes and stuff into a 3270 IBM terminal. This is in the 1980s. This is not in the 1950s. This is in the 1980s. They had no drop-down menus, no PCs, and everything was still in laminated pages at a major hospital. Okay, I'm running a little bit longer than I should. Questions, comments, feedback. If you want to throw something, it has to be soft. That's all I ask. Anybody? give me my applause and get out of here.